Okay, great. Good evening, everyone. Hello, everyone. Uh, Hi, Ajit. Hi, Yusuf. And I can see very less number of chats in the chat section. Can you guys please confirm in the chat your presence? Hello. Yes. Great. Okay. Great, guys. Can you guys please confirm in the chat my voice is audible? Yes or no? Please confirm in the chat if my voice is audible. Great. So guys, the agenda of today's session is recursion. Okay, so we will be learning about recursion. What is recursion? In which kind of problem statement we can apply recursion? Okay, and yeah, we will be seeing some questions and we will be understanding how to apply recursion code here, right? Great. So without wasting time, let's start the session. And one more announcement, guys. Today we will be having a quiz, and that quiz will be getting started at the end of the session. Okay, and the winner of the quiz, that is the top three rank, will get a shout out at our social media page. Okay, that is at our LinkedIn page. Okay, LinkedIn and our Instagram, sorry, Instagram page. Great. Yeah, guys, if you're liking the session, please uh, give a thumbs up in the chat also, and at the same time please like the video also. Okay, great. Okay, so someone is saying certificate is usable or not. So guys, again, skill is important. Certificate you can get from anywhere. Okay, so focus on the skill part. Great. So now let's start the session, guys, without wasting any time. Okay, great. Hmm. So again, we will first cover some theoretical part of the recursion, and after that we will be moving to the question part. Okay, that is recursion, right? A simple question, guys. What is recursion? Please write in the chat. Okay, whatever you know about recursion, please put it in the chat. What is recursion? Anyone? First, I want to see like what is your understanding on recursion, and after that we will discuss in depth about recursion. Okay, great. So if question is clear, my question is, what is recursion, guys? Okay, Rohan is saying function calling itself. Hmm. Mm, great. So here, function calling itself. Anyone else? Function calling itself, right? So most of the audience are saying the same thing. That is okay. What is recursion? Recursion is function calling itself, right? Right? Okay, great. Okay, this function calling itself is a way to implement recursion. Okay, it is a way to implement recursion, right? To implement recursion here. Basically, what is recursion? Recursion is solving larger problem using smaller and similar subproblem. Everyone is getting the point, yes or no? So recursion is what? Recursion is solving larger problem, right? Solving larger problem using smaller and similar subproblem. Smaller and similar subproblem. Great. Problem here. Then what this larger problem means and what this smaller and similar subproblem means, we will be discussing in this session, and you will get the clear understanding of the larger problem and your smaller and similar subproblem. Okay, but everyone is clear now. Recursion is not function calling itself. It is a way to implement recursion, guys, right? That is, when a function call itself, it is a way to implement recursion. But recursion is actually a solving larger problem using smaller and similar subproblem, right? So let's take one example so that you get the more clear understanding on the recursion part, on the definition part, right? So we have a problem statement in front of us. What is a problem statement? We have to calculate sum of n natural number from 1 to n, right everyone? We have to calculate sum of n natural number from 1 to n, right? So here it will be 1 plus 2 plus 3 plus 4 plus 5 plus dot 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 plus n minus 1 plus n, right? Yes or no, guys? If you have to calculate sum of n natural number from 1 to n, it will be the summation from 1 to n itself, right? So this is my bigger problem statement, right? Yes or no? So what we have to do, let's see whether we can divide our problem statement into smaller and similar subproblem or not. So here you can see, guys, this calculating sum from 1 to n is your bigger problem statement, right? This one here. And your smaller and similar subproblem is what here? Guys, if you know the result of sum of natural number from 1 to n minus 1, right? If you know the result of sum of natural number from 1 to n minus 1, then to this result you can add plus n to it to get the result of your bigger problem statement, right? That is your larger problem statement. So here finding sum from 1 to n is your larger problem statement. Okay, if you know the result, if somehow we are able to find the result of sum of natural number from 1 to n minus 1, right? This is what, this is your smaller and similar sub problem statement. Okay, similar sub problem statement, right? Okay, everyone. So with the help of the answer of smaller and similar sub problem, we can do some calculation on it in order to get the answer of larger problem statement. Everyone is clear now? Yes or no? Please write in the chat if this is clear. Great. So basically what we are saying ki, okay, okay, I have a larger problem statement, that is I want to find the sum of n natural number from 1 to n, right? This is my larger problem statement. In order to solve the larger problem statement, if I know the result of smaller and similar sub problem statement, that is if I know the result of sum of n minus 1 natural number, to this result I can add n to it to get the result of your bigger problem statement, right? Yes or no? This is clear? Okay, so this is nothing but your recursive relation. This is your recursive relation here, right? Recursive relation here. Okay, great. Here, right? So let's take one integer value so that you get the more clear understanding, right? That is what I'm saying here. I'm saying, okay, I need to find the sum of natural number from 1 to 5, right? I need to find sum of natural number from 1 to 5. So what we are saying ki, hey, this is my larger problem statement, right? That is finding sum of natural number from 1 to 5. And your smaller and similar sub problem statement will be what? It will be if you know the result of sum of natural number from 1 to 4, right? Then to this result you can add plus 5 to it to get the answer of your larger problem statement, right everyone? To get the answer of larger problem statement. So sum of natural number from 1 to 5 is your larger problem statement. This is your smaller and similar problem statement, right? And this is the calculation part, right, that you have to do in order to get the answer of your larger problem statement, right? This is clear now? Yes or no? Everyone present in the class, this is clear? Hmm. See, if you know the sum of natural number from 1 to 4, that is here, if you know this answer, right? This answer is what? 1 to 4. The sum is what? 1 plus 2 plus 3 plus 4, that is 10, right? The answer of sum of natural number from 1 to 4 is 10. That is, if you know this answer 10, then to this 10 you can add plus 5 and you will get the answer of sum of natural number from 1 to 5. Everyone is getting the point? Yes or no? So guys, you can see in this relation here, we have a larger problem statement, right? We have a smaller and similar sub problem statement, and we have the calculation part. So whenever you're solving a recursion code, right? Whenever you guys are solving the recursion problem, then you should keep this in mind. Okay, this smaller and similar sub problem, right? This smaller and similar sub problem, this work I will give to the recursion, right? So you will ask your recursion ki, hey recursion, go and do this work, right? Take the responsibility of solving smaller and similar sub problem, and this small work, right? This responsibility you have to take it, right? So you have to take the responsibility of calculation part. Take responsibility of calculation part, right? Everyone is getting the point. Step number one is what? You have to identify in the problem statement what is your bigger problem statement, that is your larger problem statement, what is your smaller and similar sub problem statement. Okay, the work, the responsibility of smaller and similar sub problem you will give to the recursion, right? So here this part I will give to the recursion, and the calculation part I will take care of it. Okay, I will do the work on the calculation part. I will take the responsibility of the calculation part. Okay, great. Okay, great. So now, next thing is what? I will do the dry run also, right, everyone? I will do the dry run, but before moving to the dry run, let's understand how to write the code of a recursion, right? Okay, great. So basically, guys, when you're writing the code of a recursion, right, you have to keep three things in mind. The first thing is your objective. Okay, objective. Objective is what you want to achieve from the function. Okay, that is what your function does, right? So before writing the recursion code, you should be very clear with your recursion function, what you want to achieve or what your function does. Here you can see, guys, this function sum is doing what? It is calculating sum from 1 to n. This objective is very clear in my mind, right? Objective is clear. The second thing is what? After knowing the objective, you should know about the base case, right? Base case is what? When you have to stop your recursion, right? That is when you have to stop recursive call, right? When you have to stop recursive call, or you can say when you have to terminate your condition, right? Or this, when you have to stop your recursive call. This should be very clear in your mind. Okay, base case. At this point, I have to stop my recursion call, right? Okay, or you can say when you already know the answer. When you already know the answer, right? When you already know the answer, right? That will be your base case. Okay, after that you have the recursive relation, right? Recursive relation here. Okay, great. Recursive relation is what? Recursive relation means, okay, recursive relation is what? This is the magic, right? And this magic you have to, like, this magic responsibility, okay, this responsibility you have to give to the, recursion, right? This one here, this responsibility you have to give to the recursion. And here, this process you have to trust it. Okay, you have to trust your recursion ki recursion will go and recursion will do the calculation on the smaller and similar sub problem, and it will return the answer for the smaller and similar sub problem. Okay, after that the fourth part is what? Calculation part. and the responsibility of the calculation part, you have to take it, right? So you have to take the responsibility of calculation part, right? This is clear now. So again, we have the 4 point, that is our objective. Objective is what? You should be very clear in your mind what you want to achieve from the function or what your function does. After that, you have the base case. Base case is what? The stopping condition of the recursive call. Or you can say when you already know the answer, there is no need to do any calculation. At that point, you will stop. After that, we have the recursive relation, that is telling us what? That is telling us smaller and similar subproblem. And that responsibility I will give to the recursion, and I will ask my recursion, hey recursion, please go and please solve for smaller and similar subproblem. After that, we have the calculation part, and this part I will take care of. I will say, okay, I will take the responsibility of calculation part, and I will do the calculation, and I will find the answer of the bigger problem statement. Everyone is getting the point? Yes or no? Great. Okay, this is clear now. So now if I have to write the logic, right, then the logic is very simple, guys, right? So here what I have to do, I have to calculate sum of n natural number. So we have this int sum, and here inside this we are having one argument, that is int n, right everyone? Yes or no? So here you can see, guys, int sum int n, right? So you can see, guys, here we have this recursion function, and I know the objective. The objective is what? The objective is what? This function will give me the sum of natural number from 1 to n, right? This objective I know. Yes. Now the first point is what? Objective is clear. Now I will write the base case, right? Base case, guys. Base case is what? When you already know the answer or when you have to stop your recursion call. Okay, I will write the base case. Let's first write the recursive relation and the calculation part. Okay, so recursive relation is what? Recursive relation here, right? Recursive relation is what, guys? You are saying ki, okay, in order to calculate sum of natural number from 1 to n, right? Please first go and calculate sum of natural number from 1 to n minus 1, right? And this responsibility, the responsibility of smaller and similar subproblem, this responsibility you are giving to the recursion, right? And you will assume, here you will assume, right, this recursion will go and recursion will calculate the sum of natural number from 1 to n minus 1. That is, recursion will give me the answer of smaller and similar subproblem, right? And that answer you will store inside a variable, right? Int small answer, right everyone? You have stored the answer inside the small answer variable, right? So here, if I have to find the sum of natural number from 1 to 5, then I know this recursion will go and this recursion will find the sum of natural number from 1 to 4, right everyone? Yes or no? This recursion will go and this recursion will find sum of natural number from 1 to 4, right? And that answer, that is sum of natural number from 1 to 4, the answer is what? It is 10, right? And that 10 is stored where? Inside the small answer, right? Now I have to take the responsibility of finding the answer of larger problem statement, right? How I will find the answer of larger problem statement? You can see, guys, here on this one. That is, I will return, right? This one here. I will return. hmm, I will return what? I will return small answer, right, plus n, right, to the small answer, to the sum of natural number from 1 to n minus 1. If I will add plus n, I will get the sum of natural number from 1 to n, right? This is clear? Yes or no? So the responsibility of smaller and similar subproblem statement you are giving to the recursion, and after that you are taking the answer of smaller and similar subproblem and you are doing some calculation on it to get the answer of your larger problem statement. That is clear? Yes or no? Please write in the chat if this is clear. Okay, and your base case will be what? When you have to stop the recursion call and when you already know the answer, that is if your n is equal to 1. When the value of n is equal to 1, that means you have to find the sum of natural number from 1 to 1. And in this case, you already know the answer, right, everyone? If I will say, hey, give me the sum of natural number from 1 to 1, right? Give me the sum of natural number from 1 to 1. Then the answer is what? It is 1 itself, right? Then it is 1 itself, right? I have to do nothing here. So here also, if n is equal to 1, that means I already know the answer, right? The answer is what? 1. So I will return 1 from here, right? I will return 1 from here. Okay, great. Please write in the chat if you got the clear understanding. And if anyone has any doubt, please write in the chat, okay? Great. So, okay, so here one person is saying to repeat, sir. What to repeat here, you can see we have 4 points in the recursion while writing the code. Okay, that is your objective. You should know what you want to achieve from the function. Base case, you should stop your recursive call after a certain point. Okay, so you have to stop the recursive call. When to stop the recursive call? When you already know the answer, right? When you already know the answer, at that time you have to stop your recursive call here, right? After that, you have the recursive relation. In the recursive relation, guys, what we have to give the responsibility to the smaller and similar subproblem. After that, we have the calculation part where we have to take the answer of smaller and similar subproblem, and to that answer we have to add some, like we have to do some calculation on the answer of smaller and similar subproblem to get the answer of your bigger problem statement. Right, everyone? Yes or no? Same thing here also I have done, right? That is int sum. Int sum is what? This is a function, and the objective of this function is what? To get the answer of sum of natural number from 1 to n. After that, recursive relation, where I'm asking my recursion ki, hey recursion, please go and please solve for smaller and similar subproblem. What is smaller and similar subproblem? That is, please go and please solve for 1 to n minus 1. That is sum from 1 to n minus 1. And whatever sum we are getting, that sum we are storing where? We are storing inside the small answer variable. After that, here, right? This, you can see, guys, this part I'm giving to the recursion. This responsibility I'm giving to the recursion. What responsibility I have to give to the recursion? To go and solve the problem of smaller and similar subproblem. And after that, this calculation part, this small calculation part I'm taking care of, right? Small calculation part, this I'm taking care of, right? Now everyone is clear? Yes or no? So let me first run the code on the ID, and after that I will do the dry run. Okay, let's see now. This one, give me a minute. Uh, this one here, right? So you can see, guys, I opened a online compiler. Let's use using space std, right? Using space std, namespace std, sorry, my mistake, namespace std, uh, namespace std, right? This one here, and after that, this one here, right? Let's run the code now. Let's see. Here we are getting the hello world. That is correct here, right? After that, what I will do, I will call the recursion and I will ask I will call a function, right? That is, I will create a function sum, and the responsibility of this sum function is what? It will take a variable n and it will calculate the sum from 1 to n, right? And here what I will do, I will take a variable n and I will initialize this n with, let's assume 5 here, right? Okay, great. And after that, I will print and I will print the answer on the output screen. This one here, right? So we have to implement this sum function. So here let's define the body of the sum function. That is here we have this int sum, right? Int sum, and we have this int n here, right everyone? Int sum and int n here. Okay, now we have three parts, right? Objective is clear to us. The objective is what? Objective, right? Objective is what? This sum function will do what? It will calculate sum from 1 to n, right? This is what sum function is doing here, right? After that, what I will do, I have to write the base case, right? We have to write the recursive relation, right? And we have the calculation part, right? Calculation part here. Okay, great. So basically what we have to write in the recursive relation, that is what task, what responsibility I have to give to the recursion. Okay, what responsibility I have to give? Responsibility of smaller and similar subproblem. So here we have sum, and I will ask my recursion, hey recursion, please go and please solve for n minus 1, right? Please solve for sum from 1 to n minus 1, and that sum where I will store? That sum I will store inside a variable that is small answer, right? After that, here, after that, I will get the answer of small and similar subproblem, right? So to this answer, I will add plus n, right? That is small answer plus n here, right? And I will get the answer of bigger problem statement, right? And the base case is what? When I have to stop my recursive call. That is if n is equal to 1, then I already know the answer, that is 1. Sum of natural number from 1 to 1 is what? It is 1 itself, right? So let's run the code. Let's see whether we are getting the correct answer or not. So you can see, guys, we are getting the correct answer, that is 15, that is getting printed on the output screen, right? This is clear now. Everyone present in the class, this is clear. Please give a thumbs up if this is clear. Yes. Hmm. So now let's do the dry run so that you get the more clear understanding how thing is happening behind the scene. Okay. So everyone, always first you have to follow these 4 steps to write the code. After writing the code, after executing the code, after that you have to do the dry run. Okay. After that you have to do the dry run here. So let's see how we can do the dry run. So guys, uh, hmm. so guys, when a function is called, a stack frame gets created inside the stack. Okay, so we have a program stack, that is we have a call stack, right? Okay, and this is what? This is your call stack, right? Behind the scene. And this call stack is responsible for doing what? It is responsible for storing the function call, right? When you are making any function call, that function call will get stored inside the call stack, right? So here, first you have the main function. Main function is from where the execution will start, right everyone? So we have the main function, right? We have the main function here from where the execution will start, right? And after that, in the main function, what we have done, guys, we have this int n, right, is equal to 5, let's assume. And after that, int answer is equal to sum n, right? Int answer is equal to sum n. Yes, everyone. So here you are calling a function. So calling a function. When you are calling a function, that means a new stack frame will get created inside the stack, right? Inside the stack here on the top of the previous stack frame, that is on the top of main, a new stack frame will get created, right? That is sum. And what function you're calling this sum 5, right? So sum 5 will get created here. Everyone is getting the point, yes or no? After that, after that we can assume, okay, let's assume this part, that is this is line 1, okay, line x, right? This is line Y, right? This is line Z, right? So we have three lines, that is line X, line Y, and line Z inside the sum function, right? So here also we are having X, Y, Z. Okay, X, Y, Z. So first we will be going to the X line. We will be checking the base case. Right now the value of n is what? The value of n is 5. 5 is equal to 1. 5 is not equal to 1. That means the base case is not true. And if the base case is not true, that means you will not go inside the if condition. You will go to line number Y. So you have executed line number X. Now you are standing at line number Y. At line number Y, guys, you can see you have the assignment operator. And whenever you have the assignment operator, first right hand side part will get executed, right? So here also right hand side part will get executed first, right? That is at line number Y, right hand side part will get executed, right? And in the right hand side part, what we have, guys, we are calling a function. Calling a function means what? Creating a new stack frame. So in the world of sum of 5, you are waiting at line number Y, right? And at line number Y, what you have done, you have called a function. Calling a function means creating a new stack frame, right? That is now sum. And what parameter you are passing? You're passing n minus 1. The current value of n is what? 5. 5 minus 1 is what? 4. So basically you're calling sum of 4, right? Here, right, everyone? Yes, like this. Great. After that, sum of 4 here. So now a new stack frame is created here. And again, in this sum of 4, right, in this stack frame, again we have three lines. That is line X, line Y, line Z. Again, you will check the base case. Base case is what? It is false, right? Base case is false. That is base case is false, right? Now you will go to the line Y. At line Y, guys, what we are doing? Again, we are calling a function in the right hand side part. Calling a function means what? Creating a new stack frame, right? That is a new stack frame will get created here. And now the value of n is what? Here in sum of 4, what we are doing, guys, we are calling sum and we are decreasing the value of n, right? That is n minus 1. That is current value of n is 4. 4 minus 1 is what? 3. So sum of 3 here, right? And you will wait. You will wait for the result of smaller and similar sub problem at line number Y in sum of 4. Similarly, this sum of 5 is waiting for the answer of smaller and similar sub problem at line number Y, right? This sum of 5 is saying, ki, okay, I am the larger problem statement. In order to solve me, first go and first solve sum of 4. You are standing in sum of 4. Again, you're saying the same thing. I am the larger problem statement. In order to solve me, first go and solve smaller and similar subproblem statement. So at line number Y, it is waiting. This sum of 4 is waiting at line number Y in his world, and this sum of 5 is waiting at line number Y in his own stack frame. Now you are standing at sum of 3. You are standing in the world of sum of 3. You are standing in the stack frame of sum of 3. Again, guys, we have three lines, that is X, Y, Z, right? X, Y, Z. Again, this n value is 3, that is not equal to 1. That means the base case is not true, right? Base case is not true. After that, you will move to line number Y. At line number Y, what we are doing, guys? This sum of 3 saying ki, hey, in order to solve me, first go and first solve sum of 2. So you will wait at line number Y and sum of 2 will get called. Calling a function means creating a new stack frame. So a new stack frame will get created here, right? That is sum of 2, right? And again, we have three lines, that is X, Y, Z here, right? Again, we have three lines, that is X, Y, Z here. So you are standing in the world, you are standing in the stack frame of X of, in the stack frame of sum of 2, right? Again, you will check the base case. Base case is what, guys? Base case is n is equal to 1. The current value of n is what? 2, right? The current value of n is what? 2. That is not equal to 1. Again, the base case is false. You will go to line number Y. At line number Y, we are saying, okay, in order to solve sum of 2, first go and solve sum of 1, right? So here, we will wait at line number Y and we will call sum of 1. Calling a function means creating a new stack frame, right? Yeah. Continue. And my voice is not going outside, right? Yes, sir. Okay. Okay, great. So guys, what we are doing here, we are calling sum of one, right? Sum of one here. And now guys, you can see now again you are standing in the world of sum of one, and again you have three lines, that is x, y, z, right? You are having three lines, that is x, y, z in the world of sum of one. Okay, again you will go to the base case, right? And this time the value of n is equal to 1, right? That means this time the base case is true, and the moment your base case is true, you will move inside the body of if condition, right? And in the body of if condition, guys, what we are doing, we are returning 1. We are saying ki, hey, if the value of n is 1, right? If the value of n is 1, then I already know the answer, right? If the value of n is 1, then I already know the answer, that is return 1 itself, right? So here you can see, guys, what I'm doing, I'm returning 1 from here itself. So that is this one here, 1, right? And when you encounter, right, when you encounter this return keyword, guys, two things will happen. Okay, when you will encounter the return keyword, two things will happen. That means first, this return keyword will return the value to the previous function call, that is here, and it will destroy the current stack frame. So this stack frame will get destroyed. Okay, everyone. So now what you have returned 1, and this 1 will be stored at line number y. In the world of sum of 2, that is in the stack frame of sum of 2, you are waiting at line number y, right, everyone? So inside small answer 1 will get stored. Okay, small answer 1 will get stored, and after that you will move to line number z. At line number z, what we are doing, guys, we are adding n to the small answer. The value of small answer is 1, and the value of n is what, 2 in this stack frame, that is 2 plus 1 is what, 3. And what we are doing this what we are doing with this 3, we are returning this 3 to the previous function call, right, everyone? So here, when you are encountering a return keyword, two things will happen again, right? That is, you will destroy the current stack frame and you will return the value to the previous function call, that is here, right? That is, in the world of sum of 3, at line number y, you are receiving the value 3 inside small answer, right? And after executing line number y, you will move to line number z. At line number z, what we are doing, guys, we are adding small answer with n. The current value of n is what, 3. So 3 plus 3 is what, 6, right? And what we are doing with this 6, we are returning this 6 to the previous function call, right? That is, from here we are returning 6 to the previous function call, and this return keyword will do what? Okay, behind the scene, this stack frame will get destroyed. Now you are standing in the world of sum of 4. In the world of sum of 4, at line number y, you are receiving 6 inside small answer variable, right? You will get 6 inside small answer variable. After executing line number y, you will move to line number z. Line number z is what? Small answer plus n. That is 6 plus current value of n is what? 4, right? 4. So you can see, guys, this 6 plus 4 is what? It is 10. 10 is what? 10 is sum of natural number from 1 to 4, right? And what you're doing with this 10, you're returning 10 to the previous function call. Return keyword, that means return the value to the previous function call and destroy the current stack frame, right? Now you're standing in the world of sum of 5. At line number y, you're receiving 10 inside small answer variable, right? And after that you will move to line number z. At line number z, what we are doing is we are taking this 10 and we are adding this 10 with 5, right? We are taking this 10 and we are adding this 10 with 5. That is 10 plus 5 is what? 15, right? And we are returning this 15 to the previous function call. That is, from here we are returning 15 to the previous function call, and this stack frame will get destroyed, right? And this 15 we are storing where? Inside the answer variable, right, everyone? This 15 we are storing inside the answer variable, and after that you can see, guys, I'm printing the answer on the output screen. That's why we are getting this 15 on the output screen. Okay, great. Can you guys please confirm in the chat? Dry run is clear? Yes. Please give a thumbs up if this is clear. Yes, everyone. Yes, no. Clear. What about others? I can see 46 students are there in the live class. Okay. Anything guys you're not able to understand? And this is a basic, and this is all about recursion. Okay, there are a lot of different problem. Okay, but yes, this is the base of recursion. Okay, so guys, you're able to understand how you are able to like do a problem statement with the help of recursion, and how you can do the dry run, right? And what is happening behind the scene, that is the main important part of recursion. Okay, let's take one more problem statement, right? Let's take one more problem statement, and after that we will dry run the code to understand recursion in a much better way. Okay, great. This one here. So the next problem statement is what, guys? The next problem statement is question number 2, right? That is, we have to find nth Fibonacci number, right? Nth Fibonacci number, right? Yes or no? Okay, nth Fibonacci number here. So here, this one, nth Fibonacci number. So what is the Fibonacci number, guys? Okay, so here the Fibonacci number starts from 0. You have to addition of the previous 0 plus 1 1, right? Plus 1 is 3 plus 5 is getting right. This is right. That is smaller and similar. That is, hey, getting this 21. You're getting this 21 by adding the previous two Fibonacci number, right? You're getting this 21 by adding the previous two Fibonacci number. So you can see, guys, in order to find the nth Fibonacci number, you have to get the answer of the previous two, right? You have to get the answer of the previous two. That is Fibonacci of n minus 1 plus Fibonacci of n minus 2. Okay, great. So this will be the recursive relation, right? This one here. Okay, so guys, you can see here, this is your larger problem statement, right? And these two are smaller and similar sub problem statement. Smaller and similar sub problem statement, right? And after getting the result of the smaller and similar sub problem statement, what we are doing, we are adding it, right? So this add operation, you will take the responsibility. So take the responsibility of calculation, right? Calculation part. Not audible properly? Can you guys please confirm in the chat I'm audible or not? Yes, I'm not audible. Let me check. Okay, great. Hello, 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 hello. I guess I'm audible, right? Yeah. Can you guys please confirm in the chat I'm audible or not? Now I'm audible. Yes, everyone. Now I'm audible. Yes, no. Okay, great. Now I'm audible, right? So those who are still facing problem in the audio issue, please refresh your screen and join again. Okay, great here. So guys, you can see we have the larger problem statement, we have smaller and similar sub problem statement here, right? So guys, you can see here now this one here, right? So now if I have to write the code, so I know the objective. The objective is what? I have to calculate the nth Fibonacci number. I know my smaller and similar subproblem statement. I know the calculation part. Now the last thing is what? I should know about the base case also, right? So base case is what? Base case is when you have to stop your recursive call, right? So if I will say ki, hey, give me the answer of 0th Fibonacci number, right? Give me the answer of 0th Fibonacci number. So you will say ki, hey, the answer of 0 Fibonacci number is what? It is 0 itself, right? So you will return 0, directly return 0. And if I will say ki, hey, give me the answer of the first Fibonacci number, right? First Fibonacci number. Then again you will say ki, hey, the answer of first Fibonacci number is what? 1, right? Yes or no? To return 1 from here. So if someone is asking you, ki, hey, give me the answer of Fibonacci number that is less than equal to 1, that is n less than equal to 1, right? Yes or no? Then you already know the answer. That is for 0, the answer is 0. For 1, the answer is 1. So you can directly return the answer from here. That is return n, right? This will be the base case, right? So here, if someone is asking you, hey, give me the 0th Fibonacci number, then there is no need to go and solve smaller and similar sub problem. This is the smallest problem, right? Yes or no, guys? There is no need to go and solve for smaller and similar sub problem. You already know the answer of 0th Fibonacci number. You already know the answer of 1 Fibonacci number, right? Everyone is getting the point. The base case is clear. Okay, again, in two questions, you will not be able to get the clear feeling of base case. You have to solve 10-15 questions. You will get the clear understanding how to write the base case. But hope you're able to understand the concept of base case. Okay, what this base case means and how to think of the base case, right? So here, if I have to write the code now, right? That is this one here, right? Int Fibonacci, and we have int n, right? I know the objective. Objective is very clear here, right? Objective is what? Let me check. Okay. Yeah. So objective is what? We have to calculate the nth Fibonacci number, right? Fibonacci number. After that, we are clear with the objective. After that, we have the base case. We have the recursive relation, and we have the calculation part, right? Calculation part here, right, everyone? So in the recursive relation is what? In order to calculate the nth Fibonacci number, you have to first go and solve for n minus 1 and n minus 2. So that responsibility, the responsibility of calculating for smaller and similar sub problem, right? That responsibility you will give to the recursion. That is int a is equal to Fibonacci, please recursion, please go and please solve for n minus 1, right? So this responsibility you will ask, and you will assume that your recursion will go and recursion will solve for n minus 1. And that answer you are storing inside the a variable. Similarly, you will create one more variable, that is int b is equal to Fibonacci, and here n minus 2, right? Okay, so you're asking your recursion ki, hey, go and solve for n minus 1 and go and solve for n minus 2. And that answer, guys, you are storing where? You're storing inside the a variable and b variable. After that, what you have to do in order to calculate the nth Fibonacci number, you have to add the answer of n minus 1 Fibonacci number and n minus 2 Fibonacci number, right? That is return a plus b here, right? And now, what about the base case? Base case is what? If n is less than equal to 1, then I already know the answer. Then I already know the Fibonacci number. That is, it is equal to n itself, right? That is for 0. You can see, guys, the answer is 0, right? This one here. And for 1, the answer is 1 here, right? And this is clear now. So let's see now here, this one here. And here let's run the code, right? That is, apart from this one, let's take fib, right? And let's see what we are getting here. So fifth Fibonacci number is what? 5 itself, right? Let's see. 0, 1, 2, 3, 4, 5. So you can see, guys, we are getting the correct answer, right? That is 0, 1, 2, 3, 4, 5. So the fifth Fibonacci number is 5 itself, right? This is clear now? Please give a thumbs up if the code is clear and the logic is clear. Yes. Okay. So guys, you can see it is very easy to write the recursive relation. You have to be very clear with the concept, okay? Yes or no? You have to be very clear what you want to achieve from the function, what will be the base case, what will be the recursive relation. Okay, recursive relation means what? You first have to identify a larger problem statement in your problem statement, and you have to identify smaller and similar sub-problem statement. Right, everyone? Yes or no? And that the responsibility of smaller and similar sub-problem statement, that responsibility you will give to the recursion. So simply I'm also doing here that responsibility I'm giving to the recursion, and I'm asking ki, hey, go and solve for smaller and similar sub-problem, and that answer I'm storing inside the variable, and after that I'm doing the calculation to get the answer of your bigger problem statement, right? This is clear now? Okay, great. So let's do the dry run so that you get the more clear understanding here. Okay, great. So here, what we have done, Hmm. that is, we have this int Fibonacci and int n here, right? And after that, we have the base case, that is, if n is less than equal to 1. Sir, what is the time and space complexity of this problem and how to calculate? Could you please explain them? Roshan, this is about the recursion class. Sorry, but like discussing about the time complexity and space complexity will take a 1 to 2 hour session, okay? Because I have to start from the beginning, right? So in future, if we have time, I will try to take a time complexity class, and from there I will start from the scratch, okay? To understand, like, to make you understand what about the time complexity of recursion and what about the time complexity, how to calculate the time complexity of recursion, okay? You're getting the point, Rohan? But right now the whole agenda is to understand about how to write recursion, what is recursion, okay? And if you have, like, if you know about number of recursive call, right, then the formula we have here, right, for okay, I will not discuss the formula because it will make a lot of confusion, okay? So there are different cases, and according to that cases we have to write the formula, okay? So it is not possible for me to cover each and everything in 1 hour, so sorry for that, Rohan. But yes, in future, if we are taking a time complexity class, so we will be discussing each and everything about time complexity, okay? How to calculate the time complexity of recursion, how to calculate the time complexity of normal for loop and everything, okay? Hmm, great. Hmm. So now, because right now, if I will provide you a half baked information, right, then you guys will get confused, and in future also you will be confused, okay? So that's why we will not go in the direction of time complexity right now, okay? So here, if n is less than equal to 1, that is the base case is what? Return n. Okay, this will be the base case. And after that, we have the recursive relation, right? Recursive relation is what? That is, hey, please go and please solve for n minus 1, right? And similarly, go and solve for n minus 2. That is Fibonacci of n minus 2 here. And whatever answer we are getting, that answer we are storing inside a and b, right? Yes or no? So this is the assumption. This is the assumption we are making. The recursion will do the calculation for smaller and similar subproblem. Okay. and we are trusting our recursion also, right? We are trusting कि okay, ये धोखा नहीं देगा, right? This recursion will never give you a false hope. Okay, everyone. So here, after getting the result, right? That result, on that result, we are doing the calculation, right? That is return A plus B, right? Like this. Okay, great. So now let's do the dry run, right? So that you get the more clear understanding. Okay. Again, I will not do the whole dry run. I will do the dry run of a half part. And it is your homework to do the whole dry run so that you get the more clear understanding of the recursion. Okay. So now guys, you can see, uh, let's assume this is line X. Okay. Line W, right? W. This is line X. This is line Y. And this is line Z, right? Okay, great. So we have a main function, right? We have a main function. First, a main function is getting called. So a stack frame of main will get created. Inside the main function, what we are doing, guys? We are calling Fibonacci of 5, right? We are doing what? Fibonacci of 5. Calling a function means what? Creating a new stack frame. So a new stack frame will get created here, that is Fibonacci of 5, right? Like this. Fibonacci of 5. Okay, great here. And now you can see, guys, in Fibonacci of 5, you have 4 lines, that is W, X, Y, Z. So first you will go to the line W. At line W, guys, you can see you are having a base case. Base case is what? 5 is less than equal to 1. It is false. So you will not go inside the base case. You will move to line number X. Line number X is what? Line number X is you are calling a function. Calling a function means what? Creating a new stack frame. So this Fibonacci of 5, in the world of Fibonacci of 5, in the stack frame of Fibonacci of 5 is saying, okay, in order to calculate me, first go and solve for smaller and similar subproblem. First go and solve for n minus 1. N minus 1 is what? Current value of n is 5. 5 minus 1 is what? 4. So first go and solve for Fibonacci of 4. Calling a function means creating a new stack frame. Again, you are having 4 lines, that is x, y, sorry, w, x, y, z, right? W, X, Y, Z. And again, guys, you can see your n is less than equal to 1. It is false. Again, the base case is false. You will move to the line X. At line X, what we are doing, guys? Again, we are calling a function, right? At line X, we are again calling a function, that is this Fibonacci of 4 is saying, okay, in order to solve me, first go and solve for Fibonacci of 3, right? Till that time, I will wait at line number X, right? So till the time we are not getting the result of Fibonacci of 3, this Fibonacci of 4 will wait at line number X. It will not execute line number Y and Z. Okay, so here we will wait at line number X and we are calling what? Fibonacci of 3 now, right? This one here. Again, in the world of Fibonacci of 3, you have what? You have W, X, Y, Z. Again, you have 4 lines. Again, the base case is what? It is not true. This 3 is less than equal to 1. It is not. You will go to line number X. At line number X, you are calling a function again, right? That is Fibonacci of 2. Right, everyone? Fibonacci of 2. Again, in the world of Fibonacci of 2, you are having W, X, Y, Z, right? W, X, Y, Z. Again, you will check the base case. Base case is what? 2 is less than equal to 1. It is false. So this base case is not true. You will move to line number X. Line number X is saying what? In order to solve me, Fibonacci of 2 is saying, okay, in order to solve me, first go and solve for Fibonacci of 1, right? Fibonacci of 1. And this time, guys, you can see, this time the base case is true. This n is less than equal to 1. The value of n is what? 1. 1 is less than equal to 1. It is true, right, everyone? So you will go inside the base case and you will execute the body of the if condition, right? Right, everyone? We will execute the body of the if condition. In the body, what we are doing? We are returning something, right? Return keyword will do what? It will return the value to the previous function call, that is here, right? What it will return? It will return n. The current value of n is what? 1. So it will return 1 to the previous function call, and here this stack frame will get destroyed. After returning the value, the current stack frame will get destroyed. Now you are standing where? You are standing in the world of Fibonacci of 2 and you have executed line number X and you got 1, and that 1 will get stored where? Inside variable a, right? So inside variable a, 1 will get stored, right? Now you will move to y, right? At line y. At line y, what you are doing, guys? Again, you are calling a recursion. Calling a function means creating a new stack frame. So a new stack frame will get created here, and this time 2 minus 2, right? So here the value of n is what? 0. And again, guys, you can see the base case is true. That is 0 is less than equal to 1. That is true. And you already know the answer. There is no need to solve for 0. You already know the answer. Your base case is true. So what you will do? You will return 0 to the previous function call at line number y. And you will destroy the current stack frame. So here at line number y, you have the variable b. And that b will store what? It will store 0, right? That b will store what? 0. And after that, guys, what we are doing? We are adding a plus b. So 1 plus 0 is what? 1, right? 1. And that one, what we are doing with that one? We are returning this one, right, to the previous function call. So at line number x in the world of Fibonacci of 3, this one will be stored. And this current stack frame will get destroyed, right? This current stack frame will get destroyed here. Okay. This is clear now. And again, you are calling line number y, right? At line number y, what we are calling? We are calling n minus 2. That is 3 minus 2 is what? 1, right? That is Fibonacci of 1, right? Yes or no? Fibonacci of 1 here. And you guys already know the answer for Fibonacci of 1. That is w, x, y, z. Your if condition is true, the base case is true, you will return 1 to the previous function call. That is here. And that one will get stored inside inside the b variable. After that, you will move to line number z. At line number z, you are doing what? You are adding a plus b. That is 1 plus 1 is 2. And you are returning this 2 to the previous function call. That is here. And you will destroy the current stack frame. Now you are standing in the world of Fibonacci of 4, right? And you have executed line number x, and the value will get stored inside variable a. Everyone is clear now? Like this, you have to execute the whole, like this, you have to create the whole recursive tree, okay? Please give a thumbs up if this is clear. So I'm not doing the whole dry run because it will take a lot more time. But hope you are able to understand the process, right? Everyone present in the class, yes or no? The process is clear. So this is for the homework. You have to go and do the dry run. Great. This is clear. Any questions till this point? Anything, guys, you are not able to understand? So what we have learned till now, recursion is what? Solving a larger problem statement using smaller and similar subproblem statement. Okay. And how to achieve recursion? By function calling itself, right? And after that, the second point is what? How to apply recursion. First, you have to identify bigger problem statement, and you have to identify smaller and similar subproblem statement. The responsibility of smaller and similar subproblem statement you have to give to the recursion. And the calculation part, with the help of the answer of smaller and similar subproblem statement, you have to calculate the answer of larger problem statement. That calculation you have to take care of, right? So here you can see, guys, responsibility of smaller and similar subproblem statement I'm giving to the recursion. I'm calling sum of n minus 1. And after that, to this answer, what I'm doing, I'm adding plus n to get the answer of larger problem statement. And you have to keep these 4 points in mind in order to write a recursive code. After writing the recursive code, right? After writing the recursive code, you have to do the, like in this case, first you have to compile the code and see whether you're getting the correct answer or not. If you're getting the correct answer, try to do the dry run on the code so that you get the more clear understanding how your recursion is working behind the scenes. Yes, this is clear. Okay, great. So now let's start with the quiz. Okay, let's see how much you have understood about recursion and how much you have understood about the binary search and your array class. Okay, so we will be starting with the quiz. Give me a minute. Let me check. Okay, so ma'am is joining in 2 minutes. Till that time, guys, if you have any questions, you can put the question in the chat section. Okay, anything, guys, you are not able to understand, any feedback you want to share, anything you want to like, anything extra you want to learn. Okay, any suggestions from your side, any confusion, anything. Okay, try to make the class more interactive, right? Okay, guys. So see, DSA is all about interaction, sharing your idea, sharing your understanding, right? Then only you will be able to understand. Okay, then only I will get to understand. Okay, this much you are getting the point, right? And here you are not getting the correct answer, right? So according to that, we will discuss and we will come to a proper and correct conclusion, right? Can't find lecture notes. Divansh, in the description you will get the notes, right? Okay, I will check with the management, and if still you're not able to find the notes, I will try to paste the note in the chat itself. Okay. Yeah, sir, please extend the course duration. Rohan, like earlier, what we do is like we used to take 2 hour session or 2.5 hour session, but there are less number of students, right? So that's why we have to reduce the number of duration. If you want to learn, you can go to our website and there you can check our courses. Okay, you will get the more clear understanding about each and every topic in depth. But everything, okay, guys, this timing of the session, okay, this like a 5 day session, duration of the session, everything is dependent on the audience. Okay, so there is less interaction when we are taking 3 hour session or 2.5 hour session, and when we are taking 10 days session. Okay, and there is more interaction. So if guys you will interact, we will be taking a, like we can extend the session also, right? It depends on the interaction. Great. Anything else? So we'll wait for ma'am to join, and after that we will start with the quiz.
Hey guys, hello everyone. Good evening. Sir, am I audible? Guys, am I audible? Just give me the confirmation in the chat box that am I
Okay.
audible clear?
No questions?
Hello.
Great. So
Hello.
ma'am has joined now. Okay, great.
Sir, am I audible? Hello.
Hello, ma'am.
Sir, am I audible?
Yes, yes, you are audible.
Okay. So guys, we'll start with the quiz. Go to cout.net for it, and also you will be needing two devices. Take one. Take your phone handy and go to the. I'm sharing the link in the description box. Go to this website. Put the game pin that I will share on my. Wait, let me share my screen. Yeah. I hope my screen is visible. Guys, my screen is visible or not? Just tell me in the chat box, please. Hello, guys, are you there?
Yes, ma'am. I guess your screen is visible. Yeah, you can continue.
Yeah. Okay, guys. So go to count.it and put the the game pin that I have shared in the chat box, or else you can scan this QR code and enter the game by your real name. Don't use any fake name, fake username, please, and just log in, enter the game. and you will be needing two devices. From one which you will see the question on screen from YouTube, and from the second device you will be answering the questions, and you will get 30 seconds for each question. Okay, guys. So there will be 30 seconds to answer each question, and total there are six questions. Okay, Devansh. We'll wait till 7:45. Only seven people have joined. So people are joining. The code is 186 182. 186 182. Please put the correct game pin, or else scan the QR code, or go to curve.it website and put this game pin there. The winners will be getting the shout out from our side on our social media account. So I will share the email ID in the chat box after when the quiz gets over. And please send the screenshot of the screen of that podium in the mail. We'll revert you back. Done. Okay, Devansh. We'll wait for one more minute. Only 12 people have joined yet. So we'll wait for one more minute, 1 or 2 more minutes. Guys, please join fast. Only 12 people have joined yet, till now. 13. Yeah, now people are joining. Okay, so shall we start with the game? Okay. So guys, be ready. And the game will start in 3 seconds. So request 2, 1, go. The first question here is on the screen. Which of the following statement is true regarding C++ arrays? Repeating, which of the following statement is true regarding C++ arrays? Arrays can dynamically resize at runtime. Arrays can hold elements of different data types. The size of an array must be known at compile time, or arrays can have negative indices. You have four options and 7 seconds left. Guys, answer it fast. 7 answers only. The correct option is C. The size of an array must be known at compile time. We'll move to the second question. And yeah. The second question is, in C++, which standard library function can be used to perform binary search on a stored array? Which standard library function can be used to perform binary search on a stored array? So you have again four options there: binary search, find, locate. 11 seconds there. Only 6 people have answered till now. Okay, the correct option is A. And Mahesh is leading. Third question. What is recursion in programming? What is recursion in programming? A programming technique to create loops, a programming technique where a function calls itself, a way to define variables in C++, a method for handling errors.
Guys, this question we have discussed in the today's session itself. Okay, so everyone, please give the correct answer, right? Yeah.
We are hoping for the correct answers, guys. Okay, the correct option is B, a programming technique where a function calls itself. And still Mahesh is leading. Let's see who beats Mahesh. And the fourth question, what is the key requirement for binary search to work correctly? Key requirement for binary search to work correctly. Array must be stored in descending order. Array can contain duplicates. Array must be stored in ascending order. Or the array should have a visible variable size. Sorry. Who is lagging? Might be due to my network issue or something else. Don't know, guys. It's just for today. I will sort it out till tomorrow in tomorrow's
Uh,
session.
and this question is not correct. The options are not correct, I guess. But okay, no problem. But yeah, this
The options
question, the
are not
options are
correct.
not correct. Hmm. But yeah, we can move to the next question. Okay.
On this. Yeah. The fifth question, to access the fourth element of an integer array, which of the following syntax is correct?
Hmm. So most of the question we have discussed in the class itself. So I was expecting 100% correct answer, but yeah, there are students who are giving wrong answer. I don't know why. Let's see now.
B and still Mahesh is leading. Last question. This is the last question, guys. In the recursive function, what is the stack used for to store local variables? To store local variables, to keep track of the program's execution flow, to print the output of the function, to store global variables. You have
This
15
also we have
seconds.
discussed in the today session. So most of the questions we have discussed in the today session, I guess.
Okay, the time is up, and the correct is B. We'll see the podium now. Who are the winners? And winners, please share your take the screenshot of this and send it to the mail ID that I will send in the chat box. Screenshot of this screen and send it to the mail that I have shared in the chat box, and we'll revert you back. We'll give you the shout out on our social media account. And yeah, we'll see you tomorrow again. Hope to see you all again tomorrow. So bye everyone, bye guys. So sir,
Thank
shall we
you.
end the
Thank you,
session?
everyone. Yes, yes, yes. Thank you, everyone. Please provide the feedback in the chat and please like the video also so that we get the understanding how much you guys are getting the concept and how much you guys are learning. Okay. Okay, great. So
So
that is all for
bye
today's
guys.
session. Okay. Thank you.